Hello everyone, welcome to the series tutorials on solving the quadratic equations using paper folding techniques and bicycle driving analogy. So basically in this video we are going to talk about how to solve the quadratic equation in the form of this equation where the coefficients are all positive and they have two distinct real roots, or mathematically speaking, b squared minus 4ac is greater than 0. So let's directly go to the example to solve it. I've taken this example. So at first we need a graph paper. Let's consider this as a graph paper. You can tear one of the graph paper from your graph copy. Draw an arbitrary horizontal line almost at the center of the paper, which I have already drawn over here. Then make a point that is 1 unit below the line and imagine riding a bicycle. So below this line, mark a point that is 1 unit below this line. Then imagine placing a bicycle over here. What you need to understand is that the steering or the hands of the bicycle are denoted by the signs, or the plus and the negative signs, whereas the distance is given by the coefficients. So after solving this problem you'll understand in detail. So we are going to trace out the path of this quadratic equation by using a bicycle. So let's first start with this number 3. So this number 3 represents 3 unit distance that is covered by the cycle. So we move 3 units in the bicycle. 1, 2 and 3 units. Then we have already traced the path of 3x squared. Then comes the turn of this plus sign. As we already said that the signs represent the steering or the handle. So the plus sign says that rotate the cycle as shown by the arrow. You can look here, this arrow is pointing in this direction, so rotate this bicycle in that direction. Then comes the turn of 8. So 8 means the coefficient, so we cover the distance of 8 units by using the cycle. Then similarly turn comes for this positive sign. So the positive sign says that rotate the cycle as shown by the arrow. So this arrow is going in this direction, so rotate it. Then the turn of 5 comes. Then move distance of 5 units by riding the bicycle. At last what you do is just move back to the starting place like this. By doing this process you have made a quadrilateral. So in the next step you cut this quadrilateral out of the graph paper. Then it will look like this. Then what you do is you fold the paper as instructed. So this is the paper we have cut. Now I'm using a software called GeoGebra to fold this paper. So in the first step we fold the paper in half such that it adds a crease at the middle. For doing so I'm going to fold this paper just in half like this, so that it will add a crease at the middle. So just unfolding it will get a crease like this in the center. Then in step 3 what we do is bring the bottom corners to the top blue line by pivoting from the midpoint. What it says is, let's bring this topmost corner to touch this blue line in such a way that the bottommost corner just touches the mid crease over like this. And the same process is done for this point also. Just fold the paper in such a way that it just touches the blue line and at the bottom it just meets the middle crease. So then what we do is mark these 2 points. So these 2 points are what we get as a result. Now let's unfold the paper again. Let's unfold the paper. So these are the 2 points that we got after folding the paper. Now what we do is join these 2 points to the starting point. So this is the starting point. Join the first line and join the second line like this. Now measure the 2 distances and they will give the result. So to measure the distance, you measure the distance from this red line straight to this point. So this will be 1 unit, and you also measure the distance from this point to this point, which you can clearly see it's almost greater than 1.5, so it's almost 1.7 units. So 1 and 1.7 must be the result, but you can see that these distances are on the left side of this red line. So as you can see in coordinate geometry, if you look in the left direction, it will give the negative results. So -1 and -1.7 are the approximate results that are given by the paper folding technique. But you might have some question, because the answer that we get from paper folding is -1 and -1.7, but by using the real algebra we get the result to be -1 and -1.6667. So are we doing something wrong in origami? So the answer is there is always some error in paper folding. One reason is the least count of graph paper, because it cannot measure the lengths less than 1 mm. And folding cannot be 100% accurate, and some lengths error always occur while folding. And the main reason is construction itself isn't accurate in reality. Let's say an example. Suppose you want to draw 5 cm by the ruler in a paper, but you can't be sure whether the measured length is accurately 5 cm or not, because it could be something like 5.02 cm or 4.99 cm. So construction itself isn't accurate in reality. So that's the reason why we don't get the exact result from paper folding. But if you have some ideal situations like ideal folding, or some software that does some folding as we did in GeoGebra, so then this will give the exact result. So okay, let's make a slight change in the previous question and make it like this, so that the second coefficient is negative instead of being positive. So I'll take the same example with the same coefficients, but I'll change the sign of this 8 and let's see what happens. We'll start sequentially from the beginning, and we will proceed and we will see the changes in it. So first we take a graph paper, draw a horizontal line, then mark a point below the line, and imagine playing a bicycle. Then, as we have already discussed, steerings are denoted by signs and the distance are given by the coefficients. So at first we'll move 3 units in the bicycle like this. Then the turn comes of negative sign, so here comes the change. The negative sign says that flip the arrow and rotate as per the direction. So first we flip this arrow like this and rotate, so the rotation will be in this direction now onwards. So it's the turn of 8, so move 8 distance. Then the turn of the positive sign, it says that rotate the cycle shown by the arrow, so in this direction. And again the turn of 5 comes, so move a distance of 5 units, and then we are done. Then move back to the starting place where you began. Then cut the quadrilateral. At first we fold the paper in half as usual. So then this will give a crease like this. Then we unfold the paper. Then we bring the bottom corners to touch the blue line and also touching the middle crease simultaneously. And same with this vertex, we bring to the blue line and then just touching the middle crease like this. So in step 4 we mark these 2 points and again unfold the paper like this. So these will be the 2 marks thus obtained. So after folding we get these 2 points, then as previously done we are going to join these points to the starting point, as this is the starting point in this case. As you can see, now we measure the distance from here to here, which is 1, and we measure the distance from here to this point, which is 1.7. As you can see, the previous question and this question is just similar but only reflected in signs. So as this distance is to the right side of this red line, so we are getting the positive result. So the roots of these question will be 1 and 1.7 approximately. So the errors is same as the previous one. We always get an error in folding. So in the next video we will discuss another model of quadratic equation in the form of x squared minus bx minus c and ax squared plus bx minus c, and this will be quite different from the 2 forms that we discussed today. Till then, thanks for watching.